Hello everyone, and welcome to the final presentation of Group 4, Group D. Our capstone project is QUP, a student result issue reporting system. My name is Zadkiel Saah, and my roles for this project were Cloud Architect, QA Specialist and Documentation Lead. My partner, Kwame Acheampong, served as our full-stack developer and database administrator. I'll begin by outlining the core problem at GCTU. When students discover a discrepancy in their published results, such as missing grade or an incorrect score, or a course omitted entirely, there is no structured digital way to report it. Currently, reports are made informally to lecturers or departmental staff. This leads to missing paperwork, students being entirely unable to track the progress of their complaints, and administrative staff having no centralized view of outstanding issues. QApp solves this directly. It is a cloud-native platform where students can securely log complaints, attach evidence, and track resolutions while giving administrators a unified dashboard to manage the lifecycle of every issue. As cloud architect, my primary responsibility was designing the provisioning the AWS infrastructure to host the application freely, strictly within the AWS free tier. We implemented a highly available three-tier architecture. When a user accesses the application, their HTTP request hits our Amazon EC2 instance, which acts as our computer tier. The EC2 instance runs both our static frontend on port 8080 and Node.js, Express API on port 5000. And for our data tier, we completely decoupled storage from compute. Structured relational data lives in the managed Amazon RDS PostgreSQL database, and unstructured data, specifically the evidence files uploaded by students, is stored in Amazon S3. Let me take you into the live AWS console to demonstrate how this infrastructure was provisioned and secured. Here in our EC2 console, you can see a running T3.micro instance named QApp server. We chose Ubuntu as our OS. We ensure our application survives crashes or server reboots. We installed a product process manager called PM2. PM2 daemonizes our Node.js backend and frontend so they continuously run in the background. Security group. Security was a massive priority of our cloud deployment. If I click on the security group for this EC2 instance, you see our inbound firewall rules. By the principle of least privilege, we only allow HTTP traffic on port 5000 and 8080. Notice that SSH restricts access on port 22 and is strictly accessed by the developer IP addresses. We intentionally did that so that we will not leave the 22 open to the world to protect against automated brute force attacks. AWS console idea. Next, look at our database layer. We provisioned an Amazon RDS Postgres instance. A major cloud security practice is network isolation. If we look at the RDS security group, you will see that it does not accept traffic from the open internet. It only accepts inbound Postgres traffic on port 5432, coming specifically from our EC2 instance security group. Furthermore, we configured the database connection pool in our code to enforce SSL encryptions, ensuring data in transit between EC2 and RDS is encrypted. For file storage, we used Amazon S3. You can see the orange badge indicating that block all public access is active. No one can access these files via a guessable public URL. To allow our backend to upload files securely without exposing root credentials, I ensure the Acheampong create a dedicated programmatic user named Q app backend. I wrote a custom JSON policy that explicitly grants only S3 put object and S3 get object on this specific bucket ARN. If the server is ever compromised, the blast radius is strictly limited to this one bucket. Okay, so let's move to the next one, which is the CloudWatch. So for operational monitoring, we utilized Amazon CloudWatch. So let's enter one of the instances, per instance metrics, and CPU utilization, which is CPU utilization here. Here you can see the performance metric for our EC2 instance over the last few days, proving the server is healthy, routing traffic, and operating well within the free tier limits. So finally, as QA specialist, I handled end-to-end testing and troubleshooting. Deploying to the cloud is never without hurdles. For example, we initially faced an issue where PMs repeatedly restarted without binding a spot because our backend startup script didn't recognize PM2's execution context. We also had to debug an SSL connection timeout between EC2 and RDS because AWS requires encryption code connections by default, which our local code wasn't configured for. Looking to the future, our next steps will be adding an application load balancer and AWS certificate manager to enable HTTPS and implementing a WebSocket connection for real-time push notifications. I will hand over to Kwarteng to walk you through the application UI and aligning software engineering. Thank you, Zadkiel. I am Kwame Acheampong, and I served as a front-end developer, back-end developer, and database administrator. Our system was originally a basic prototype built on Firebase, but then for this capstone, I completely re-architected it, replacing the Firebase with a custom Node.js Express REST API and the Postgres database to give us full control over our relational data. So I'm going to demonstrate the live application. Okay, so for the sign up, let's enroll a student 24254011111. For the student ID 242540111 at live.gctu.edu.gh. Let's test at gmail.com and password GCTU is the best. GCTU is the best. Sign up. like as you can see, when a student registers, their password is never saved in plain text. In my backend controller, I use the library called bcrypt to sort and hash the password before it's stored in Postgres. Okay, so GCTU is the best. When a student logs in, the server generates and signs a JSON web token, which is like the JWT. This token is sent to the front end and attached to the authorization header of all feature requests, making our API completely stateless and highly scalable. So let's for his report issues, here on the student dashboard, the student can view their profile, track past complaints, and submit a new result issue. Let me demonstrate submitting an issue. So let's say the course code I had is DN201, course title, Intro to IT, K, missing grade. So then you have to select as evidence. Let's see, okay, this. When I click submit, it's crucial to know that this file is not saved to our ECT instant local hard drive. If we did that, our server would eventually run out of space. Instead, my Node.js backend intercepts the multi-path from data using a middleware called Malta. It holds the file into memory briefly and uses the AWS SDK to stream it directly into our Amazon S3 bucket. Only the resulting S3 object is saved in our database. Yes, so that's what happens when I click on the submit button. Now, as you can see, it was submitted and we can track our complaints we made. You can track our result issues we made. As you can see, this is what we just submitted. Exactly. So let's move to the admin. Now let's look at the administration side. I will log in as super admin. Okay. The UI you see is basically dynamically rendered based on the role payload instead of the GWT. Furthermore, we have strict role-based access control and middleware protecting the backend. If a student tries to send a GET request to this admin endpoint via Postman, the server will reject it with a full 3 forbidden error. Here, the admins have a centralized view of all issues. They can change to resolved. When an admin updates a status, the backend performs a transaction. It updates the issue status and sets a record into the status history table for auditing purposes and generate a notification for the student. That's what happens. That's what happens in the admin dashboard. Okay. So as the database administrator, let me walk you through the Postgres schema I designed. We migrated away from NoSQL to a relational module because university data is highly structured. We need tables for students, admins, complaints, result issues, notifications, and status history. Notice the foreign keys. Every complaint and result issue is strictly tied to a student ID. This enforces referential integrity, meaning an issue cannot exist without a value student attached to it. That's what happens. Looking at the backend architecture, this is our authentication middleware. Okay, so it extracts the token, verify the cryptographic signature against a secret key, and attach the user data to the requested object. Yes, so that's what happens. So, by offloading our states to RDS and S3 and managing our APIs with PM2, we successfully migrated this project into a robust cloud native application. The Capstone gives us an incredible hand-on experience designing schemas, building secure APIs, and deploying production infrastructure across the AWS ecosystem. Thank you for watching our presentation.